Okay, so our topic for this afternoon is introduction to motor controllers. Okay, so first we have the first part of the topic, which is all about motor controller basics. Okay, so what is a motor controller? So it is a device or group of device that serves to govern in some predetermined manner the performance of an electric motor. A motor controller might include a manual or automatic means of starting and stopping the motor, selecting forward or reverse rotation, selecting and regulating the speed, regulating or limiting the torque, and protecting against overloads and faults. Okay, so from your answer on the Mentimeter, so some of you mentioned, no? The protecting against overloads and faults, so overcurrent protection. Also starting and stopping the motor. Okay, so you have given the correct answer. So in summary, a motor controller is a device, no? It could be a single device or a group of devices. So its main purpose is to govern, no? Govern or to control the performance of an electric motor. Okay, so we have two common types of motor controller. So first we have the direct online or the DOL, and we have the reduced voltage starter. So for the direct online starters, so it is the simplest of method of starting motors. So it usually used to start motors of low HP or horsepower rating, typically not more than 5 horsepower. So the direct online starting is sometimes used to start small water pumps, compressors, fans, and conveyor belts. So the direct online, so you could apply or you could use the direct online starter on low HP motors, no? Typically not more than 5 horsepower. Okay, so its main application is for water pumps, compressors, fans, conveyor belts, no? For conveyor belts. Then we have the reduced voltage starter. So if we go beyond the 5 horsepower rating of a motor, so there is now the so-called lock current, no? A lock rotor current. And the lock rotor current can be 6 times, no, the normal operation or the normal operating current of the motor. For example, if your full load current of the motor is 10 amperes, so when the motor is starting, so 6 times, so that would be 60 amperes. So it may damage your conductor, damage your breaker, and also it could damage the motor itself. So a way to reduce the starting current is to reduce the voltage applied to the motor. So if we reduce the voltage, so basic Ohm's law, we will also reduce the current because the resistance on the motor is constant, no? Because the resistance of the motor depends on the winding. Okay, so reducing the voltage can be achieved by 3 methods. So by using a resistor and connecting it in series with the motor windings, by using a transformer, and by changing the wiring configuration on the motor during starting. So the first method, no, using resistor, so this is called the primary resistor starting, no? Then the second one, using a transformer, so this is the auto transformer starting. And the third one, no, by changing the wiring configuration, so that is the Y delta starting. Okay, so we have here reduced voltage starters. So we will discuss individually those 3 types of reduced voltage starters. So we have primary resistor starters. So this starter allows a large resistor to be connected in series with the supply voltage for a specified amount of time until the motor is running approximately 65% of the full RPM, so the revolutions per minute. So 65 percent. So if the motor is starting, so the primary resistors which are connected in series will engage, no, it will engage. Then after sometimes the motor is now running 65% of its full RPM, then it will disengage. No, one of its advantage is the voltage that is dropped by the resistor is turned heat. So that is the one of the disadvantage, no, disadvantage, not an advantage. So the voltage is turned into heat. So this can cause overheating, no? Overheating to the motor circuit conductor and to the motor itself. Then we have the auto transformer starter. So it works by allowing the motor to start at a lower voltage using an auto transformer with multiple taps on it. So unlike the primary resistor starter, it does not give heat. Its only advantage is sometimes the auto transformer is expensive. And if you have a higher, voltage, no, motor, or a high HP motor, then it will require a larger auto transformer, and your motor starter now will be also larger, and it will occupy some space. Okay, next we will go to Y delta. I'll go now to the Y delta starter. Okay, so this starter is utilizes the reconfiguration of the motor terminals to reduce the voltage. So the motor is start up at a lower voltage by configuring it to the connection of a Y, no? And then sometime reconfiguring it to connection into delta. Okay, so at the starting of the motor, the winding of the motor is configured as Y, so that we could reduce the voltage and thereby reducing the lock rotor current. Then after some time, so usually by using a timer, no, so 3 to 5 minutes, so depending on the HP of the motor, it will reconfigure, no, into delta. So by that moment, so the motor can now function in its full RPM or full speed and can give a full torque. Okay, now we have motor control components. Okay, motor control components. So first we have the contactor. So this is the heart of the motor controller, no? So contactors are electromechanically operated, no, with switch. So these are switch. When you say electromechanically, so by electromagnetism, so that provide a safe and convenient means of connecting and interrupting branch circuits. So this is a contactor, no? So the brand is ABB, no? So as you can see, we have here L1, L2, L3. So I hope it will be clear on your cell phone screen. You have T1, T2, and T3. So when we have L1, L2, and L3, that is the supply, no? The wire, so the wire of the supply. So if you are going to wire this one, so the supply wires will connect on these terminals, no? These three terminals. Below is the T1, T2, and T3. So that is the terminal wherein the terminal of the motors will be connected. Of course, the contactor can be reversed if it is a AC contactor, but if we are going to follow the standard, no, the standard, so we must put the proper wires to its proper terminals. Then this one, the last terminals with the last pair of terminals. So these are the auxiliary terminals. So as you can see, it is NO. When we see NO, normally open. Okay. So we will discuss further what is normally open and normally closed later on this discussion. No? Then we have push button. So this type of hand switch is a two-position device operated with a button that is pressed and released. Most push button switches have internal spring mechanism returning the button to its out or unpressed position for a moment operation. It comes in a momentary or maintained action. So the takeaway for this one is the push button is momentary. So when we say momentary, for example, if you push that one, it will on or off the circuit. Then if you will remove your finger, then it will go back to its normal state. Either it is that is normally open or normally closed. So this is a push button. So when we have the green is usually run or go. Then red is stop or idle. So, then we have selector switches. So these are actuated with a rotary knob or a lever of some sort to select one of two or more positions. So like the toggle switch, selector switches can either rest in any of their position or contain a spring return mechanism for momentary operation. Okay, so this is a selector switch. So the selector switch, you could select different positions. So the common usage of a selector switch is in your electric fan. So the electric fan uses a selector switch. But in motor controllers, so the selector switch is mainly used to set your motor controller. Either it will be manual or automatic. Then you have limit switch. So these switches are operated by machine motion. So they are useful in automation and control application. So when we say machine motion, so if this part of the switch here will be pressed, by maybe a action of a machine or a certain weight, so it will turn or turn off the motor controller depending on the normal state of the switch, if it is normally open or normally closed. Then we have the control relay. So used as auxiliary device to switch control circuits and large motor starter and contactor coils, and to control small loads such as small motors, solenoids, electric heaters, pilot lights, and other relays. So the control relay can act like a contactor but in small motors, So if it is now larger motors, we will use the contactor. So usually if we are going to have our motor controlled by a PLC, programmable logic controller, so the output of the PLC will be feed into the controller, and the output of the controller, this control relay, then the output of the control relay will be feed into the contactors. So by that, so we could say that the controller will serve as the bridge between the PLC and the contactor. Then we have pilot light, a small mushroom shaped bulb used as signaling device. So each color represent a state in the motor control operation. So these are the common, no? Common these are the common pilot lights, no? So we have the color green, so it indicates run or the motor is running. Red, stop or idle. Yellow, sometimes it will use the orange. It will indicate as fault or emergency, so there is a problem on the motor. Then last, we have the timer delay relays or the timer relay. So timer delay relays are divided into two general classification: the on delay and the off delay. So the contacts of this relay delay on changing their position for some period of time. So if we say on delay, so the on delay is during the moment wherein the timer has been supplied with a voltage source, then it will act on its setting. Then after some time, it will, for example, set 5 minutes, so it will disengage, no? For the off delay, so at the start it will be set, or it will act on its normal setting. In after 5 minutes, or depending on the setting of the timer, it will change state, no? Either normally open or normally closed. So the usual purpose of the timer relay in motor controllers is to control contactors in a sequential manner. So especially the Y delta, no? The Y delta controller. So because the Y delta utilizes the timer relay in the process of changing from Y configuration to delta configuration.